Okay, this is McGraw-Hill Chapter 1, Section 4, Graphing, or I should say solving linear inequalities. So this is the same process as solving equalities, meaning with equal signs, with one difference. When you get to two-step form, like we are here, if the number with the variable is negative, we're going to have to flip this sign. You'll see this in some examples. So here's the first one. This is example 1, page 77. We have 3x minus 7 greater than 2 times parentheses x minus 4 minus 1. So we solve it just like we did the equalities. Distribute first, get 2x minus 8. Collect like terms. And now notice we're in the same situation that we were in section 1, where the variable on both sides. So I'm going to subtract the 2x over, which gives me x minus 7 equals negative 9. Add the 7 over, and I get x is greater than negative 2. So that means at negative 2, the arrow is telling me which way to shade. And then whenever there's not a line underneath, whenever it's less than or greater than, it's a parentheses going in the direction we're shading. If it's less than or equal to or greater than or equal to, it's a bracket. So here's the algebraic notation. Here's the graphical notation. The interval notation is we come from the left, and the first thing we hit is parentheses negative 2. So that's what we write. Comma, we're going to positive infinity, so we put infinity. And whenever there's a negative infinity or a positive infinity, there's always parentheses, no bracket. So when you work these problems for me, you must have all three representations. You must have algebraic, which is x greater than negative 2. You must have graphical, where it shows negative 2 parentheses, shading towards positive infinity. And then you've got to have parentheses negative 2, comma, positive infinity, parentheses. Got to have all three. If you don't have all three, I will mark it wrong. Here's example 2. Okay, in terms of this one, page 78. Now, this is already in two-step form, and I notice that the variable has a negative number, so I know I'm going to have to flip the sign when I see this. So I add the 5 and get 7. Divide by the negative 2. I flip this less than sign to greater than, and I get x is greater than negative 7 halves. So here's my 0, and make sure you put 0 on your number line. If you don't put 0, I will mark it wrong. So I got to know, I need 0, so I know you're on the right side of the number line. So I put negative 7 halves, parentheses, because there's no line. It's shading to the right. The arrow is telling me which way to shade. And so if I want the interval notation, I have parentheses, negative 7 halves, coming to positive infinity, parentheses. Again, you must have all three representations, algebraic, interval, graphic. Here's example 3, page 79. Same process. We have negative 6 times parentheses x minus 3 greater than or equal to 2 minus 2 times x minus 8 parentheses. First thing we're going to do is distribute. When we distribute here, we get negative 6x plus 18. We distribute it here, we get negative 2x plus 16. Combine like terms here, we get negative 2x plus 18. Add the 2x over, we get negative 4x plus 18 greater than or equal to 18. Two-step form. Negative with the variable, we're going to have to flip the sign. Subtract 18 from 18, we get 0. And that's perfectly all right to get 0, because 0 is a possible answer. Divide by negative 4. Even though it's 0, we're still dividing by a negative number, so we have to flip the sign. So we get x is less than or equal to 0. So here we start at 0, because it's less than or equal to, it's a bracket, and it's going to negative infinity. So as we come from the left, we're coming from negative infinity, parentheses negative infinity. As we keep going, we're stopping at bracket 0. I hope you see how the interval notation is just a shortened form of the graphical notation. And the graphical notation represents the algebraic. I got to see all three, because I got to know that you know how to do all three, because I don't know who you're going to take for college algebra. So I don't know what they're going to require, so if you know how to do all three, you're in good shape. Last example problem. Example 8. Here's our fractions. Negative 5x plus 2 over negative 3 greater than x plus 2. So what I did was rewrite it and put x plus 2 over 1. Now I'm multiplying the whole equation by negative 3 over 1. When I multiply negative 3 over 1 over here, the negative 3's cancel, and it leaves me negative 5x plus 2. When I multiply negative 3 over 1 times x plus 2 over 1, it gives me negative 3 times x plus 2. And I put the parentheses so I know that I've got to distribute that negative 3 to both. If I don't have the parentheses, it looks like negative 3x plus 2, and I forget to distribute. Distribute, I get negative 3x minus 6. Add the 3x over, I get negative 2x plus 2 greater than negative 6. Two-step form, I can see that I'm going to have to flip the sign. Subtract the 2, I get negative 2x greater than negative 8. Divide by negative 2, flip the sign. Negative divided by a negative is a positive, so I get x is less than 4. So here's my 0, here's my 4. As I come from negative infinity, here, I got parentheses negative infinity. I'm stopping at parentheses 4. So x is less than 4 means I'm starting at 4 and going to the left forever. So that's the reason, it's pointing that way. So that's the reason I'm shading. And if I read it from left to right, I'm coming from negative infinity here and going to 4 parentheses. Whew.